All right, we started yesterday this lesson, so let's try to finish it up. Solving right triangles. So we basically solved for some missing sides, didn't we? All right, they gave you an angle, and you could find the sides. What if they don't give you any angles at all, except for it being a right triangle? How in the world would we be able to solve for the angles? Well, you wouldn't be able to unless you know what we're going to do today. All right? So these are called inverse trig functions. Inverse. Well, I don't know if I could call them inverse trig functions. But we're going to talk about, let me talk. We're going to talk about the inverse sine, inverse cosine, inverse tangent. But if we do one, the rest are kind of the same. So let's just take a look at this. So here is a situation that we're going to encounter. If the sine of A is equal to, we'll start off with this. I was going to jump to the example, but I'll do this first. All right, what if we wanted to solve for A? Did we talk about this? It seemed like we talked about this in another class. Yeah, I think my pre-calc class we're doing this stuff, okay? And I even said something to them yesterday. I was like, the stuff we're doing right now, we're doing in my geometry class. So that's kind of where you're at right now. All right, so the sine of A equals X. So that's where I did that in the pre-calc class. What we're going to do is we want to get A by itself. All right, now, what if you had something like this, like 3x equals 12, and you want to get x by itself? What would you do with that 3 that's next to the x? Yeah, you divide by 3, okay? Super easy, going back to pre-algebra, right? What about this, though? What if you wanted to get A by itself? Divide by A. Did we divide by x over here? Did we divide by x over here? No, we kept the x there. Okay, it's not sin. It's not. We never say sin. We say sine. All right? That's kind of what I was looking for you to say. It's not correct, but it's a very reasonable thought, okay, that I would get rid of the sine by dividing by sine. But we have to think about it a little bit. We got to think about what the sine is. What is the sine? Is it a variable? Like right here, I would divide it by 3. 3 is an actual number, isn't it? So I can divide by an actual number. Is the sine an actual number? No, it's just a word that tells us what? What does it mean to be a sine? Okay, S-I-N or S-I-N-E for the actual full word. What does it mean for that word sine? It means it's a word that shows the relationship, right, or the ratio between what? The opposite side of a right triangle to the hypotenuse of a right triangle. That's what the sine means. Can I divide by something like that? No, because it's not a variable, all right? It's not a letter. It's not a number. We can't divide by it. But we can do something else. Why did we divide by a 3 in this situation? No, why? Yeah, to get rid of it. But what allows us to divide? Because this 3 was doing what to this x? It was multiplying. So why did we choose division to get rid of it? Because it's a what? It's what compared to multiplication? Okay, it's opposite. It's a better math word, though. It's the inverse, okay? See? Inverse. All right, it's the inverse. So what's the inverse of multiplication? It's what? It's division, right? So what we have to do is take the inverse of the sine. We took the inverse of a multiplication here, right? Which is division, and they cancel each other out, all right? What we're going to do is take the inverse of the sine. Let me move this over just a little bit so I can write something here. And let's move this over because I'm going to put some stuff in here, all right? And let's change colors. So watch. What I'm going to do, I'm not going to divide by the sine. I'm not going to divide by the sine, but I'm going to take the inverse of the sine. I don't know if you did this in Algebra 1 or not. It seems like every time I say, did you do this in Algebra 1, everybody says, no, I don't know what you're talking about. But I don't know if this is even an Algebra 1 topic. It's been years and years since I taught Algebra 1, so I'm not even sure. But did you do something like this 2 to the negative first. Did you guys do negative exponents? Denise is shaking her head. Did you do it at Red Lion? Okay, good. Just seeing. What does that mean? Do you remember what it means? Okay, I'll show you what it means. So 2 to the negative first means we take the inverse of 2, or the reciprocal of 2. So it's 1 over 2. Very good. Everybody hear that? Noah, you're pretty chatty today. You need to settle down. All right? You're all hyped up. I don't know. Just listen. Okay? You say something every time I say something. So just watch what we're doing. So 2 to the negative first means we take this and we take the inverse of it. Okay? I'm getting somewhere with this. So I want to get rid of the sign. So what do? We can't divide by the sign, but we can take the inverse of the sign. You see, this is the symbol for taking the inverse of something. Taking something to the negative first power means we take the inverse of it. So what I'm going to do is I'm going to take the inverse sign of the sign. So what do you think taking the inverse sign of the sign is going to do? What did it do here? You got rid of it. That's right. They cancel each other out. But remember, in algebra, if I do something to one side, what? I got to do it to the other side, right? Just like we divided this by 3, divided this by 3. If I take the inverse sign of this, what do I have to do over here? I got to take the inverse sign of this, right? So watch. That will cancel with that. So what am I left with then? If that inverse sign and sign cancel each other out, what am I left with? A equals the inverse sign of x. A lot of times we'll put it in parentheses, so let's do that. Okay? You're like, well, what does that mean? I get it. I understand. It's the first time you've seen this. You have no idea what I just did right there. Let's do an example and I'll show you, okay? But keep that in mind, what we did. How do I get rid of a sign? I take the inverse sign of both sides. Make sense? That's all I want you to know at this moment right now. In a couple minutes, okay, we're going to learn something else. So here's an example. So I could give you something like this. I could say that yeah, I see what they're doing. Let's do this. Sine of 60 equals, it's not really an example, but it'll help do this. And that's a true statement. The sine of 60, okay, is the square root of 3 over 2. Just let's go and do this. Right, there it is right triangle. Okay, this would be the 30. This would be the 60. That would be a 1, correct? Remember doing this? Okay, what's the short side? Be half the hypotenuse. What's the long side? It's the square root of 3 times the short side, so it would be the square root of 3 over 2. Okay, you with me on that? So what is the sine? The sine is the opposite over the hypotenuse. Would you agree that that's a true statement, that the sine of 60 is the square root of 3 over 2? Yeah? Okay, you agree with this triangle, right? If the hypotenuse was 1, this would be a half, this would be square root of 3 over 2. What's the sine of this angle right there? It's the opposite, this one, square root of 3 over 2, over the hypotenuse, which is the square root of 3 over 2. I just want to make sure you know that that's a true statement, okay? It is. What I'm going to do here is this. I want to get the 60 by itself. And I'll show you why. This isn't, I shouldn't even put example there. This is kind of like a pre-example, okay? What I want to do is get rid of that, or I want to get 60 by itself, take this sign, put it over to the other side. So what's going to happen? Well, I'm going to take the inverse sign of this, correct? Let's push this over so I can write it over here. And then what am I going to do to the other side? If I took the inverse sign of this to get rid of the sign, what am I going to do here? Take the inverse sign of this. What happens? That cancels. So 60 degrees equals the inverse sign of the square root of 3 over 2. Let's talk about that a second. What does that mean, the inverse sign of square root of 3 over 2? That means when you see the inverse sign, they're asking you, what angle? Did you hear me? Okay, what angle, if I take the sine of that angle, will I get the square root of 3 over 2? Look at this triangle. What angle, if I took the sine of it, the opposite over the hypotenuse, will I get the square root of 3 over 2? Which angle? The 60, right? So if I took that 60 and took the sine of it, I would get opposite over hypotenuse, which is the square root of 3 over 2. That's what this is saying right here. Okay, this thing right here says, what angle? All right, so sine to the negative first is asking, give me an angle. If I take the sine of that angle, I'm going to get the square root of 3 over 2. That's what this means. And what angle is it? It's 60. How do we do that on a calculator? Well, I'm glad you asked. Let's do it. I got to change this, don't I? Mode. Change it to degrees. I'm getting better at remembering this now. Let's see. Enter and clear. Okay. So here's how you do this. You can put this into a calculator and get 60 degrees as an answer. But I want you to know like what you're doing when you're or what it's asking for when you do this. So if I have the sine to the negative first or the inverse sine of some number, I'm asking, or they're asking, what angle, if I take the sine of that angle, am I going to get the square root of 3 over 2? What angle is it? It's 60. Let's put it in a calculator. All right? Sine to the negative first. On this calculator, now again, everybody's got calculators that are just a little bit different, but for the most part, everybody would hit second function sine. Watch, second function sine. See what it does? It puts sine to the negative first. And then what do we put after that? Square root of 3 over 2. So let's do that. So square root is also second function. There's a square root of 3, right? I'll close the parentheses and then divided by 2. I'll close parentheses again, right, because you got that first parentheses there. Everybody see that? So that's how you would put this into your calculator. And you hit enter, and look what it gives you. It gives you 60. What does that mean? That means 60 what? 60 degrees, because when they give the inverse, what are they asking you for? As soon as you see sine to the negative first, cosine to the negative first, tangent to the negative first, what are they asking for? What kind of, what are you finding as your answer? You're finding an angle, okay? You're finding something in degrees. It's an angle. Make sense? All right, so if it's the sine to the negative first, you're asking what angle, when I take the sine of that particular angle, am I going to get the square root of 3 over 2, all right? And then you punch it in a calculator and you get 60. Or you could always just draw this, right? Put your 30, 60, 90, put your 1 for the hypotenuse, put your half for the short side, put your square root of 3 on this side. So for instance, let's say you didn't know it was 60. Let's say you had no idea, all right? You drew this triangle and you're like, okay, what is the inverse sine of square root of 3 over 2? You're like, okay, well that means, Mr. Hammer said, that means I'm looking for an angle, right? I'm looking for an angle. If I take the sine of that angle, I'm going to get square root of 3 over 2. Well, let's try 30. What if I took the sine of this angle? What if I took the sine of 30? What am I going to get? Come on, think about it. The sine of 30. 1/2, very good. Okay, why 1/2? Because it's the opposite over the adjacent, correct? So that's not going to work because it's not square root of 3 over 2, right? So if I take 30, I'm like, okay, maybe if I take the sine of 30, that's going to give me square root of 3 over 2. But does it? No. The sine of 30 gives me 1/2. Okay, let's try the other angle. Let's try 60. What is 60 going to give me if I take the sine of 60? Opposite over hypotenuse, which is the square root of 3 over 2. So what angle am I using then? I'm using 60. So that's why that answer is 60. Yes? I could have written it like this. I could have said, what's the inverse sine of 1/2? Use this little drawing right here. What does this mean? It means what angle, if I take the sine of it, will I get 1/2? 30, that's right. This angle right here. Because if I take the sine of that, That gives me a half, doesn't it? What if I did the inverse cosine of square root of 3 over 2? Okay? Again, what does this mean? This means what angle, if I take the cosine of it, this time it's cosine, will I get the square root of 3 over 2? Well, let's try the 60. What's the cosine of 60? It's adjacent over hypotenuse, isn't it? All right, so what is it? What's the cosine of 60? It's a half. Well, that's not that number, is it? So let's try this one. Let's try the cosine of 30. What's the cosine of 30? It's adjacent over hypotenuse. Yep. What angle gives me this? 30 degrees. That's right. That's the angle that gives me the square root of 3 over 2 when I take the cosine of it. Is that helping a little bit? Let's do another one. Would you say 28? We're out of here? Okay. Let's do another one just so that we kind of get an idea. Let's do a 45. What if I said, what is the inverse sine, I kind of gave it away, of square root of 2 over 2? Now, I picked this number for a reason because it's a number that I said we need to remember, okay? So when you see square root of 2 over 2, what kind of a triangle do you think of? A 45, 45, that's right. Okay? You with me on that? All right. So what are they asking for here? They're saying, what angle, if I take the sine of that angle, will I get the square root of 2 over 2? Well, remember, on a 45, I'm going to make the hypotenuse 1. This is going to be square root of 2 over 2, and this is going to be square root of 2 over 2. So really, I only have one choice. It's 45. That's right. Because if I take that 45, what's the sine of that angle? It's opposite over hypotenuse, which is the square root of 2 over 2. So what angle am I using? I'm using 45 degrees. It's the same exact thing if I ask for the inverse cosine of square root of 2 over 2, isn't it? All right. So what angle, when I take the cosine of it, am I going to get the square root of 2 over 2? It's still 45 because the cosine is adjacent over hypotenuse. The opposite and the adjacent are the same numbers, aren't they? So the sine and cosine are going to give you the same thing. So the cosine of that angle is the square root of 2 over 2. So what angle is that again? That's 45 degrees. Make sense? All right. Let's do a real example now. That was just to get you warmed up. All right, just to get you thinking about what it means to be an inverse cosine or inverse sine. We haven't even talked about tangent, but it's the same thing with inverse tangent. So let's do an example. This is example 3. Now this time, it's not going to be one of those special triangles like a 30, 60, 90 or a 45, 45, 90. So we're going to have to use a calculator. All right, and I showed you how to use it. Okay, we're going to do it again. So what if they give you this side is 3 and this side is 5, and they ask you to solve for angle A, that angle right there. Before today, there's no way in the world you would ever be able to figure out what that angle is. Now, you could find this missing side, couldn't you? Just real quick, what's this missing side right here? 4, that's right, 3, 4, 5 triangle, correct? But you don't even have to find that side right there, unless they ask you to find everything. And sometimes they do. Sometimes they ask you to find everything. Let's do it. They don't actually ask you in this problem. They just ask you to solve for A. But I'm going to solve for the triangle. You're like, what? Solve for a triangle? How can a triangle be equal to something? But what do you think they really mean when they say solve for the triangle? Solve for all the missing stuff, right? All the missing sides. All right, so I'm going to call this ABC. If this is A, this 3 right here is A. If this angle is C, this is C. If this is angle B, this is B. All right. Now pretend they didn't tell you the 4, so that's one of the things you had to find. What if it wasn't a 3 and a 5? What if it was some weird numbers? What would you do to solve for B? Pythagorean theorem, right. Okay, you'd find a Pythagorean theorem. You could do it here if you wanted to, but it's a lot easier recognizing it's a 3, 4, 5 triangle. Now, here's the key. This is the new stuff today that we would have never been able to do until today, is finding angle A. All right, how do I find angle A? Well, here's what I'm going to do. Look, I got all three sides here, don't I? I'll tell you what, let's do this. Let's pretend, because we don't even need to know that side right there to solve for A. Look at angle A. What two sides do they give me? They give me the opposite, and they give me the hypotenuse. That's right. So just that right there tells us which trig function we're going to use. They give you the opposite, they give you the hypotenuse. Which trig function are we going to use? The sine, because it's opposite over hypotenuse. So that's the first thing I'm going to do. And that was really important. Everybody understand why we use the sine here? Because of the sides that they gave us originally. All right? This was the opposite, or this is the opposite, this is the hypotenuse, so we're going to use the sine. The sine of what? Which angle am I trying to find? A. Everybody with me? Equals. Now let's put the numbers in. What are my numbers? 3 over 5. That's correct. Okay? Now we're at that point that I was just showing you earlier. Now I got to solve for A. How do I get A by itself? How do I get rid of the sine? I take the inverse of the sine. Very good. Now you could put sine to the negative first here, cross them out, but you know what's going to happen. What's going to happen to that sine? It's just going to go away, isn't it? But I also have to take the inverse sine of the other side. So let's just do it like this. Do you see the algebra? I have to get rid of sine. I don't divide by the sine, but I do take the inverse of the sine. All right? And I do that to both sides. On the left side, it'll cancel out. On the right side, I'm going to get the inverse sine of 3 over 5. So now you're ready just to put that into a calculator. What's it going to give you? What's the answer in the calculator going to give you? It's going to give you what? Angle A. It's going to give you that angle right there. Okay? So let's do it. Turn it back on. All right, so what are we going to do? Second function sine of what? 3/5. So 3 divided by 5. I like to close the parentheses. Everybody see that? Isn't that exactly what we wrote right there? Yep, hit it, and you get that number right there. What is that number? It's angle A, isn't it? It's the degree measure of that angle. So 36 point, let's round it to 1 decimal place. So what's that going to be if I round it to 1 decimal? 9, right? Because that 6 rounds that 8 up to a 9. Okay? And there you go. Oh, one thing I almost forgot. It's degrees, right? Because it's an angle. So 36.9 degrees. That's what they're asking for. And you're good to go. We good with that? How could you find angle B? Well, you know angle A now, don't you? It's 36.9. There's really 2 ways to do this. They're not supplementary. These 2 angles are not supplementary. They're what? They add up to 90, don't they? So it's not supplementary. What's the word? Starts with a C. They're complementary. All right. I'll be here all day waiting for you to answer. All right, so they're complementary. What does complementary mean? They add up to 90. So I could just do what? So 90 minus 36.9. And then you get 53.1. Okay, but, and that might be okay. Let's find it a different way. Remember I said there's 2 ways to do this? That'd be the easiest way for sure. But let's do this. Let's forget that we even know angle A. Let's pretend we didn't know angle A. We can still find this. Is it sine though? With the information, you could if you put that a 4 right there, okay? But sometimes you don't need to find this. And we don't. We don't have to find that side right there. Because sometimes it's a little difficult to find that side. But just with these 2 sides that they gave us, could we solve for angle B? Yeah. Which trig function are we going to use though? We got 3, we got 5. What is the 3 to this angle B? It's adjacent, right? And what is the 5? Hypotenuse. Which one has adjacent and hypotenuse? Cosine. That's it. So watch what I'm going to do. I'm going to go to the cosine of angle what this time? angle B, because I'm trying to find angle B. Now, if we do it this way, we should come out to 53.1, shouldn't we? All right, that's what I'm trying to do here. So the cosine of B is equal to what? Adjacent over hypotenuse. So this is 3 over 5 again. But this time, it's cosine, all right? So watch what I do. How do I get rid of the cosine? Take the inverse cosine, and that'll cancel out. That'll give me a B. I also have to take the inverse cosine of the other side. We good? All right, let's do it. Inverse cosine, second function cosine, 3 divided by 5, 3 divided by 5, and then hit enter, and there it is. Look, 53.13, blah, blah, blah. All right, so were we right? Yep, angle B is 53.1 degrees. You got to be careful sometimes, though, all right, because this is a rounded number, isn't it? That 36.9, it wasn't exactly 36.9. So this isn't exactly 53.1, is it? It's 53.1301, blah, blah, blah. All right? So you got to be careful, because sometimes if this is not rounded correctly, or sometimes even if it is rounded correctly, you may not get the correct rounded answer here. All right? So it's good to do it both ways. Let's do another one. What do you think? You getting the hang of this? This inverse thing, so we can find the angles? Yeah, it's a big deal. It really is in math. Let's do another one. This one says solve the triangle. Okay, so you got to find everything. This one is 11. This one's 17. We don't know that one. A, B. Oops, it's not B. A, C, B. All right, here we go. Let's do it quick. We got 3 minutes. Sorry it took so long today, and we still got a little bit more to do, but this will get you going pretty good. This is example 4, by the way, if you want to write that down. So what can we do? Let's solve for C. Let's do that first. Okay, we don't even worry about the angles just yet. Let's solve for C. How would I solve for C? Unfortunately, it's not like a 3, 4, 5 or a Pythagorean triple. So I'll do Pythagorean theorem. So it's C squared equals 11 squared plus 17 squared. Okay, I'll do the math for you. C is about 20.2. This is an approximation. I should put a squiggly equal right there. All right, you can do the math. Running out of time, so I'll just do it for you. Okay, we good with that? So squiggly, 20.2. Now, here's the thing. Since this is an approximation, when I do my trig stuff, I really want to try to avoid using that side. Why do I want to avoid using that side? It's approximate. It's not exact, okay? I want to get as close to exact answers as I can, so I'm not going to use this. I mean, it'll be super close if you used it, but I'm not going to. So let's solve for A first, all right? So solve for angle A. So look at the two sides that they gave us originally. They gave us this 11 and this 17. What is the 11? What is the 17 to angle A? So 11 is what to angle A? Adjacent. Which one is 17 to angle A? It's opposite. So I've got opposite and adjacent. Which trig function am I going to use now? Tangent. That's right. So I'm going to go to the tangent of angle A equals the opposite. Which one is opposite? 17 over the adjacent, which is 11. Now the next part you should be able to do, take the inverse tangent of both sides, so that cancels out the tangent on the left, but it gives us an inverse tangent on the right, 17 over 11, and we're basically done. We just throw that into a calculator. I'll let you do that again because of time. So that's approximately 57.1 degrees. All right, that one right there is 57.1 degrees. What's that? Approximately. Yeah, approximately. Because you get some big decimal after it, okay? Everybody with me? All right, one more to do. Now, technically, you could go 90 minus 57.1, all right? But it may not be as accurate as we want it to be. So let's use trig function. We're not packing up yet, are we? Didn't think so. So let's do this angle right here. So what is the 11 and 17 to this angle? What's 11? That's opposite, and 17 is adjacent. So it's opposite. It's flipped, isn't it, when I do the other angle? So now I got the tangent of B is equal to 11 over 17. Solve for B. What's B? It's the inverse tangent of 11 over 17. Put that into a calculator, and you're going to get about 32.9. And that's, 32.9. And that is what you would get if you would have gone 90 minus 57.1. But sometimes it doesn't work that way, all right? You'll get super close to it, but sometimes it's not exactly. But we're trying to learn trig, so let's do our trig, all right? All right, so let's see. Oh, I didn't write down the thing. Let me look. I think so. They change the rules sometimes, but... So what are we doing? So you should have done 1 through 15 already, right? And then 16 to 23 is what this is going to be. All right, so tomorrow I'll collect them both, 16 to 23. So basically you're doing 1 to 23, okay, except it's just split into A and B. All right, everybody good? We'll just go over this tomorrow. Won't do anything else new. All right, and then that'll be all we do tomorrow. Yep.